screen. So here it is. The integral from 3 t to the 4th plus 2, everything to power, just 1, and times t to the 3rd dt. So in this particular situation, we have two options. One option would be to distribute, and then you're done. So let me show you that option. This is not what we want to do because we want to practice the substitution, but let's do that first. So we have 3t to the 7th plus 2t to the 3rd and dt. Regardless of the method, we have to get the same thing. So 3t to the 8th over 8 plus 2t to the 4th over 4 plus a constant c. Yes, I can simplify and rearrange. 3/8 t to the 8th plus 1/2 t to the 4th plus c. So this is good, and that's the final answer. But let's use substitution. So I'm going to write it again. 3t to the 4th plus 2, t to the 3rd dt. So what would you recommend? What should the substitution be? There is nothing we can do to t to the 3rd. It's a simple polynomial. And we can use any letter you like. So let's say w. This should be the substitution. 3t to the 4th plus 2. So 3 to the 4th plus 2. Now, let's determine dw. Without dw, I cannot move on. Can anyone give us the dw for this function? Please. Try it even if it's wrong. It's okay.
12t to the 3rd.
Yes. So this is 12t to the 3rd. This
dw?
is dt.
Oh, okay.
So on this side, it has to be the same variable. And dw is not the derivative. The derivative will be indeed 12t to the 3rd. But that's not dw. dw is not the derivative. dw is the derivative times the variable inside, which is dt, the differential of the variable inside the function. So 12t cubed dt, I have t cubed, I have dt, but I don't have the 12. So that's very easy to make up. Or you solve for t cubed over dt. That's a different option. So t to the 3rd dt will be dw over 12. So this is replaced by dw over 12. And this has to be replaced by w. So the new integral is the integral from w dw over 12. Of course, I will put 1 over 12 in front. So we jump here. 1 over 12. Which function prime is w? Which function I have here that I can differentiate to get w? Anyone, please? Which function we differentiate to get w?
W squared.
Over 2, indeed. Plus a constant c. Multiply 1 over 24. Instead of w, I have to go back and put this in. So 3t to the 4th plus 2, everything squared, plus a constant c. So if you go back, we did a similar problem in class. So please practice with these just for more confidence. Any questions on this problem at any step? Do I need to explain anything? Do you need me to go back to any step?
No, I'm good. Thank you.
Okay, excellent. Next question, anyone? Brian, any question? Anything you need help with?
Nope.
Okay, in that case, we'll continue with the substitution rule. So we only had 3 examples, 2 last time and 1 right now, today. So let's choose anything else before we look at the definite integrals. So let's choose something else. Do I get to choose now? I think I'll choose. I will choose 21. 21 has the integral from dx over 1 plus 7x. And of course, x cannot be negative 1/7. Why? Can anyone tell us why x cannot be negative 1/7?
Because that makes the denominator 0.
And the fraction undefined. Awesome. Thank you, thank you, thank you. Okay, so let's use a substitution. What will you substitute? Any letter you like. Let's use u this time. Any letter except t. I'm sorry, except x, because we have x. Here, any letter except t. Here, any letter except x. So let's say u. What do you think we should substitute, and why? It's okay if you're wrong. What do you think?
1 plus 7x.
Exactly, 1 plus 7x. And the question is, we can never simplify this. 1 over x is simple. 1 over x plus 1 is not, because there is nothing I can do to simplify it. The same thing with 1 over 1 plus 7x. When the denominator has two terms, I'm kind of stuck. Awesome. But now I need du. Because see, this function or the integral has dx in it. When I move from one variable to another, I must have the d of that new function or new variable, if you want. So we have to identify or determine du for this function. What should I write?
Seven dx.
That's it, 7 dx. I differentiate this, I get 7, but I have to multiply by dx because it's du. It's not u prime. Awesome. So now I have dx. I'll divide both sides by 7, and I get dx equals du over 7. So then this piece is du over 7, and this piece is u. When I move from an integral in x, I completely move to an integral in u. I cannot have a mixed situation. It's not allowed, it's not possible. So this integral has only x in it. The new integral will only have u in it. So dx is replaced by du over 7. And 1 over 1 plus 7x is replaced by 1 over u. Of course, it's a property. I can move 1 over 7. It's a factor. The integral from 1 over u du. As you notice, the whole thing changed from x into u. There was no x left. So now we have to identify which function we differentiate to get 1 over u. There is only one function that we differentiate, and we get the answer 1 over u. What do you think? Anyone, please? It's okay if you're wrong. Just say something so I can correct it. Anyone, please? I can't believe we're stuck on the function whose derivative is 1 over u. I cannot believe that. We cannot get stuck. Which function we differentiate and get 1 over u? Is anyone with me? Did you all go swimming? That's the only thing allowed. If you disappeared and if you did not go swimming, then you are considered absent.
I don't know.
Yes, you do. Of course you do. When we differentiate natural log u, we get 1 over u. I know you do. So 1 over 7 natural log, I have to go back to the variable, which is 1 plus 7x. 1 plus 7x. It has to be the absolute value. Good. How do we feel about this one? Any questions about this problem? Are we okay with this? Brian, are you okay with this?
Yep.
Okay. Any questions? Anyone? Okay. Do we need to select another before we move on to the definite integrals? Maybe we want to select from here with e. Maybe we want to select with natural log, something with natural log. Anyone? Would you like to select anything else? I think we should work on at least one more. Any preference? Anyone? Please, anyone? Okay, I will pick 29. So we have the integral from e to t dt divided by 3 plus e to t. Okay, so let's use y this time. Let y be. What do you think? It's okay if you're wrong. What do you think the substitution should be?
Is that e plus or e or 3? I'm sorry. Is that 3 plus or 3t?
No, 3 plus. Sorry about that.
3 plus et.
Yes, 3 plus e to t, of course. Because again, the same idea. The denominator cannot be simplified. If this is in the numerator, we can. But if it's in the denominator, we cannot. If it's in the numerator and it has only one term, we can separate. Who knows? Okay, excellent. So what about dy? Because if I don't have dy, I cannot continue. Can anyone give us the dy for this function?
Et
E to t
plus e. Oh, dx.
dt. Awesome. That's it. It's the derivative times dt. Why dt? Because t is the variable. If I had e to dx, I would have written dx. But I don't have e to dx. I have e to t, so I have to stick with the same variable. Okay, perfect. So now this becomes so easy, so easy. Why? E dt is this. And this is y. So it's dy over y. Pretty easy. So dy over y, which function prime is 1 over y.
Natural log.
Yes, of the absolute value of y, of course. So I'll continue one more step because I have to go back to the variable. What is the variable? 3 plus e to t. I don't need absolute value for 3 plus e to t because this is always positive and this is always positive. So I will use parentheses plus a constant c. Here, I cannot. I cannot change the absolute value bars into parentheses because this could be positive or negative. That's why I need the absolute value. But here I don't because this is positive and this is positive. Good. So do you think we need another example or we can move on to maybe an example with natural log? So let's choose an example with natural log. Which one you prefer? this, 32, 33, 34. So let's choose one example with natural log.
32.
32. Okay, very good. So let's look at 32. 32 says natural log x squared over x dx. Of course, x has to be greater than 0 because log does not exist, and the denominator cannot be 0. Perfect. So let's look at this and decide what the substitution should be. Let u be. An indication of what u should be is also look in the problem and see whatever I choose, do I determine du very easy or easily? In other words, it's already in the problem. That's what I meant. Sometimes more than one substitution works. Sometimes we're going to embark on a path and it will not work and we'll go back to the drawing board. It's okay. But we have to try something. So what do you think? Say it again.
X.
We never use u equals x.
Oh.
Because it's not going to change anything.
So natural log squared.
Just natural log x. Very good. What is du in that case? U is natural log x. Now I want to determine du, the differential, not the derivative, the differential of u.
The 1 over x.
Not the derivative, the differential.
dx.
Exactly. The differential is 1 over x times dx. Here it is. Dx times 1 over x. That's my du. And what is this?
U squared.
That's it. So therefore, I continue here. I have the integral from u squared du. Much more user-friendly than what I had before. So what is the answer here? I need a function that I differentiate to get u squared. What will that be?
U cubed over 3.
That's it, plus a constant c. And we have to go back. I have to go back to this. I have to replace u by natural log x to the third, everything divided by 3, plus a constant c. Can I check this? Yes. When I differentiate this, I have to get that. Natural log x squared divided by x. And I will. Because when I differentiate this, I get 3. The 3 goes away. I get natural log x squared times the inner function prime, 1 over x. So I can always check